Good day and welcome to today's class. Today's class is a continuation of our previous classes on applications of SURDS in solving triangles. In today's class, we shall be solving more exercises on application of SURDS. Question 2 says we should calculate the length of x and y below. This gives us a quadrilateral, and from all indication, if this angle is 60 degrees, let me name it A, B, C, D, and let this be E. From my observation, triangle ABC can be said to be an equilateral triangle because if the two base angles are 60 degrees, it therefore means that angle A will also be 60 degrees, and that makes them all to become an equilateral triangle. And also in triangle ACD, this is said to be 45 degrees, which makes triangle ACD to become an isosceles triangle, meaning angle X is equal to angle Y. So if we can get angle X or angle Y, then we can get the other. Alright, so let's see how we can get angle X. If you consider triangle AEC, we have it that this is a perpendicular, that means this is 90 degrees. If I should cut AEC out, it gives me something like this. This is AEC, where this is said to be 90 degrees and this is 60 degrees, while AE is said to be 6. So I'm asked to find X, where X is said to be the hypotenuse. Now, with the application of trig ratios, we have it that 6, which is the opposite side to angle 60 degrees, 6 divided by X will be equal to sine 60 degrees, because this is the opposite to the angle and this is the hypotenuse, where opposite, the ratio of opposite to the hypotenuse side is said to be the sine of angle 60 degrees. So I'm going to make X the subject of the formula, where we cross multiply. That gives us X sine 60 degrees. X sine 60 degrees is equal to 6. Dividing both sides by sine 60 degrees to make X the subject of the formula, we have it that X is equal to 6 divided by sine 60 degrees. And from our trig ratios, we already know what sine 60 degree is. So if you go back to where it was derived, we have sine 60 degrees to be said to be equal to root 3 over 2. So this becomes 6 divided by root 3 over 2. And when you simplify further, you have X to be equal to 6 times 2 divided by root 3. And when you simplify this, you have X to be equal to 12 divided by root 3. Rationalizing this by multiplying both the numerator and denominator by root 3, this gives us 12 root 3 divided by 3. And when you simplify, 3 into itself is 1, into 12 is 4, leaving us with X to be equal to 4 root 3. So that means that the value of X is said to be 4 root 3. And if this is said to be 4 root 3, Y is equally said to be 4 root 3, because triangle ACD is said to be an isosceles triangle. So that means we have it that X is equals to Y and is equals to 4 root 3. So they are both 4 root 3. Question 3, that the angle of elevation of X from Y is 30 degrees. If side XY is equals to 40 centimeters, how high is X above the level of Y? So I'm going to interpret this question using a triangle. That the angle of elevation of x from y is 30 degrees. If this can be said to be the triangle, that the angle of elevation of x from y is 30 degrees. So if this is x, y, let me call this z. If xy, which is the hypotenuse, is 40 centimeters, how high is x from the level of y? So we are asked to find the height xz. So this can be represented this way, and once you have gotten to this stage, you can then apply the trig ratios in getting your h. Kindly like this video as you watch, while we encourage you to subscribe to our channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. We also recommend that you share the link with your friends so that they can also benefit from this project. So, in order for us to solve for h, we are going to apply the trig ratios by saying, to this angle 30, h is said to be the opposite side. So the ratio of the opposite side to the hypotenuse side is said to be equal to the sine of that angle theta, which we have derived at the last class. So that means that h divided by 40 is equal to sine 30 degrees. And when you cross multiply and make h the subject of the formula, this gives us h to be equal to 40 sine 30 degrees. And when you substitute the value of sine 30 degrees, you have your h to be equal to, what is sine 30 degrees? You can go back and find out. Sine 30 degrees is said to be half, or 0.5. This becomes h is equal to 40 times half, so that our h is said to be equal to 20 centimeters. Question 4. That you should find the length marked A and B in the triangle ABC. Okay, now this is triangle ABC with angle 45 degrees. Invariably, that means this is also angle 45 degrees. And that gives me an isosceles triangle, because the base angles of an isosceles triangle is said to be equal. And once the base angles are equal, therefore means that the other two sides are also equal. That means whatever I get as my A is equal to my B. So let's solve for A. You can either use sine or cos depending on which you want to solve. So opposite, which is B, over the hypotenuse, which is given, I'm using the ratio of one of the unknown side to one of the known side, so as to get the unknown sides. If you want to find the ratio of two unknown sides, it will be very difficult for you to do that, because you can't solve for two unknowns unless it is a simultaneous equation. So opposite over hypotenuse is said to be the sine of that angle theta. Substituting, I have B divided by 2 is equal to sine 45 degrees. And sine 45 degrees, from our knowledge, is said to be, sine 45 degrees is said to be 1 over root 2, or root 2 over 2. That means B divided by 2 is equal to root 2 over 2. And when you cross multiply, by multiplying both sides by 2, if I multiply here by 2 and do same to this, I'll have my B to be equal to root 2. So B is equal to root 2, and as we said, A is equal to B and is equal to root 2 as well. Question 5. We should find Q in triangle PQR. Q happens to be the hypotenuse side of this, and if you look at this angle is also said to be 45 degrees, because some of angles in a right angle triangle is said to be 180 degrees, and this is 90 minus 45 gives you 45. So this side will also be equal to this side, so it therefore means that side QR is also 4. You can either use Pythagoras theorem in solving this, or the trig ratios. But since the topic we are dealing with is on trig ratios, let us use it in solving this. So this becomes opposite, which is 4 over q is equal to sine 45 degrees. And we said sine 45 degrees is root 2 over 2. So 4 divided by q is equal to root 2 over 2. And when you cross multiply, you have q root 2 is equal to 8. And dividing both sides by root 2, you have q to be equal to 8 divided by root 2. So we then rationalize the denominator, and this becomes q is equal to 8 root 2 divided by 2, which is said to be 4 root 2 centimeters. So that means our q is said to be 4 root 2 centimeters. You can also use Pythagoras theorem in solving this, for we have it that q squared is equal to 4 squared plus 4 squared. This gives us q squared is equal to 4 squared is 16 plus 4 squared is 16. So our q squared is equal to 32. While q is said to be the square root of 32. But root 32 can be simplified to be root 16 times 2. And that gives us root 16 times root 2. For root 16 is a perfect square, which is said to be 4. So 4 times root 2 is said to be 4 root 2, which is the same thing as what we got here. So whichever way you take it, you still arrive at the same answer. Kindly use the comment section to interact with us on areas where you still find difficult. Question 6 says, XYZ is an isosceles triangle with side XY being equal to side XZ and is equal to 6 centimeters. And angle YXZ is equal to 120 degrees. That we should calculate the length of side line YZ. Now all you need to do is to sketch the triangle XYZ. So if this is triangle XYZ, let this be my triangle XYZ. And I'm told that XYZ is an isosceles triangle with side XY being equal to side XZ, and is said to be equal to 6 centimeters. And triangle YXZ, which is this angle they are referring to, is said to be 120 degrees. That we should calculate the length of side YZ. Let it be this. Let me call it X. So this is an isosceles triangle and is not a right angle triangle. So all you need to do is to draw a perpendicular to bisect angle 120 degrees, making this to be 90 degrees. It therefore means that it has ended up bisecting this into, let me call this A and A, because it has bisected line YZ into 2 equal parts, as well as the angle, because it's an isosceles triangle. And if this is 120 degrees, then it means that angle Y will be equal to angle Z, because base angles of an isosceles triangle are said to be equal. Now when you subtract 120 from 180, it gives you 60. It therefore means that this is equal to 30 degrees and this side is equal to 30 degrees. So if you look at it, if I call this N, you agree with me that triangle XYP is equal to triangle XNZ, because they are both similar. So side YZ is equal to the sum of side YN, which is A, plus side NZ, which is also A. Since YN and NZ are said to be equal, so when I solve for A in any of the triangles, I can just multiply it by 2 and it gives me the length of side YZ. So using trig ratios, I will consider triangle XYN. So in triangle XYN, this is angle 30 degrees, and I have the ratio of the adjacent side, because this is the opposite, this is the adjacent, this is the hypotenuse. So the ratio of the adjacent to the hypotenuse side is said to be equal to the cosine of angle 30 degrees. So let's substitute. The adjacent is said to be A, while the hypotenuse is said to be 6, is equal to cos 30 degrees. Cos 30 is said to be root 3 over 2. So when you substitute, you have A divided by 6 is equal to root 3 over 2. You then substitute to make A the subject of the formula. When you cross multiply, you have 2A to be equal to 6 root 3. And dividing both sides by 2, you have your A to be equal to 6 root 3 divided by 2, giving us A to be equal to 2 into itself is 1, 2 into 6 is 3, and our answer becomes A is equal to 3 root 3. But the question said we should find YZ, and if A is equal to 3 root 3, and this A also is equal to 3 root 3 because they are equal, then side YZ is equal to 2 times 3 root 3, which is equal to 6 root 3. So our YZ is said to be equal to 6 root 3. Don't forget to use the comment section to interact with us if you are having any challenges. Also, turn on the notification bell so as to be notified whenever a new video is being uploaded. Question 7 says, a cone has a circular base, a perpendicular height of 42 centimeters, and a semi-vertical angle of 30 degrees, that we should calculate the slant height of the cone. So I'm going to sketch the cone. If this is a cone with a circular base, that it has a circular base, a perpendicular height of 42 centimeters. So let this be the perpendicular height of 42 centimeters, and a semi-vertical angle. This is a semi-vertical angle of 30 degrees. We should calculate the slant height of the cone. This is the slant height of the cone. So with this sketch and with what I have drawn, I can now sketch out the triangle. So this can be seen to be like this. This is the slant height, this is the angle 30 degrees, and this is the height, which we are told is 42 centimeters. Now I should calculate the slant height. You can apply trig in solving this. Just like I said, the first step in solving a problem is understanding the problem. Your ability to interpret the problem or sketch it gives you 50% of the solution. So this can be represented in trig ratios as 42 divided by L is said to be equal to sine theta. For sine theta is said to be the ratio of the opposite side to the hypotenuse side. So this becomes 42 divided by L is equal to sine 30 degrees. And sine 30 degrees, we have already established that it is equal to half. So this is said to be 42 divided by L is equal to a half. So you cross multiply and make L the subject of the formula. L is said to be equal to 42 times 2, and L, which is the slant height, is said to be 84 centimeters. So 84 centimeters is said to be the slant height of this cone. Question 8. That from the top of a tower 60 meters high, two ships are seen in a direction due south. The angles of depression of the ships from the top of the tower are 45 degrees and 30 degrees respectively. That you should find the distance between the ship. While reading the question, I have been able to visualize the problem, and that gives me an edge in solving the problem. If this is said to be the tower, let's take this to be the tower. I'm on top of this tower, and from here you can visualize two ships. One is said to be, we're told that the angle of depression of the ships from the top of the tower are 45 degrees and 30 degrees respectively. Angle of depression is said to be the angle between the vertical plane and the eye. So this is the angle of depression of 30 degrees, while this is said to be the angle of depression of 45 degrees. So how can we we're asked to find the distance between the two ships. So if this is ship A and ship B, we are asked to find this distance. Let me call it X. Let me letter them A, B, C, and D. Now, considering triangle CDA, this is 90 degrees. If this is 30 degrees, then definitely this is going to be 60 degrees. And considering triangle CDB, if this is 45 degrees, this is also said to be what? Angle 45 degrees. So with this, I can then get whatever I am asked to find. I was also told that the height of the tower is 60 degrees. So it therefore means that this is 60 centimeters, sorry. So with this, I should be able to get the distance between the two ships. How do I get the distance between the two ships? If I can get the distance DA as well as the distance DB, when you subtract DA from DB, it gives you the distance AB. So how do I get that? I'm going to apply the trig ratios. Considering triangle CDA, we have it that, let me call this Y. We have it that 60 divided by Y is said to be equal to, this is opposite over adjacent, is said to be tan 60 degrees. I'm going to look for Y, so that Y tan 60 degrees is equal to 60, and Y is equal to 60 divided by tan 60 degrees. For tan 60 degrees, as we have shown, is said to be equal to root 3. So you substitute root 3 for tan 60, you have your Y to be equal to 60 divided by root 3. And when you rationalize, Y is said to be 60 root 3 divided by 3. 3 into itself is 1. 3 into 60 is 20. Y is therefore said to be equal to 20 root 3. So I have gotten my distance Y to be equal to 20 root 3. What I'm to do next is to find the distance DB. So, considering triangle CDB, we have it at 60 divided by, let me call this whole place, P, 60 divided by P is said to be equal to, this is opposite over adjacent. It is also equal to tan 45 degrees. And when you cross multiply, you have 60 is equal to P tan 45 degrees. Dividing both sides by tan 45, you have P to be equal to 60 divided by tan 45 degrees. I will then substitute at this point. For tan 45 is said to be 1. This now becomes 60 divided by 1. And 60 divided by 1 is said to be 60. So I have gotten P as well as dA, of which we said x is equal to P minus y. So therefore x, which is the distance between the two shapes, is equal to 60 minus 20 root 3. And in short form, x is said to be equal to, I will now factorize out 20. This is 20 into bracket 3 minus root 3 as your answer. Question 9 says, without using tables, find 1 divided by sine 60 degrees, given that sine 60 degrees is equal to 2 sine 30 degrees cos 30 degrees. All you need to do is to replace sine 60 degrees in this expression with 2 cos 30 degrees cos 30 degrees, and then get the values for cos 30 degrees and sine 30 degrees and substitute, and that gives you your answer. So we have it that 1 over sine 60 degrees can be said to be equal to 1 divided by 2 sine 30 degrees cos 30 degrees, because they said sine 60 degrees is equal to 2 sine 30 degrees cos 30 degrees. So simplifying this is said to be equal to 1 divided by 2 times what is sine 30 and cos 30 degrees. If you go back to the trig, sine 30 degrees is said to be 1 over 2, while cos 30 is said to be root 3 over 2. So this is times 1 over 2 times root 3 over 2. This is over 1. So 2 will cancel out itself, leaving you with 1 divided by root 3 over 2, which is equal to 2 over root 3. And in order for you to simplify this, you have to rationalize. So 2 over root 3 is said to be equal to 2 root 3 over 3. So this is your answer. Question 10 says, if tan x is equal to 1 divided by root 3, we should find cos x minus sin x, such that 0 degrees is less than or equal to x and x is less than or equal to 90 degrees. Now you can solve this problem using a right angle triangle. If I should sketch this as a right angle triangle ABC, because we are told that x lies in the first quadrant. So if this is x, it therefore means that tan x, which is equal to opposite over adjacent, is equal to 1 divided by root 3. That means that the opposite side, which is this side AB, is said to be 1, while the adjacent side, which is BC, is said to be root 3. So all I need to do is to find the side AC. AC, let it be y. For the hypotenuse has a relationship with cos x and sin x. So once you're able to get your AC, you can then solve for cos x and sin x. And how can we get our y? We can get our y using Pythagoras theorem, because the value of x is not given. So using Pythagoras theorem, we have it that the hypotenuse squared is equal to the sum of the squares of the other two sides, which is this. So let's solve for our y. Y squared now is equals to 1 plus root 3 squared is said to be 3. So that y is equals to 4. Y squared is equals to 4. And y is equal to square root of 4, which is said to be 2. So if y is equal to 2, we can then get our cos x minus sine x. So that cos x now is said to be the ratio of the adjacent side to the hypotenuse side, which is equal to, the adjacent side is root 3 over 2, okay, and the sine x is equal to the ratio of the opposite side to the hypotenuse side, which is equal to 1 over 2. So you can then substitute these values and solve for your cos x minus sine x. For cos x minus sine x now will be equal to root 3 over 2 minus 1 over 2. And since the denominators are the same, you can subtract the numerators. This is equal to root 3 minus 1 all divided by 2. And this is your answer. That brings us to the end of this class. In today's class, we have been able to look at more examples on problems that has to do with trigonometry. In the next class, we shall solve more exercises on applications of SURDS. Kindly like our videos as you watch, while we encourage you to subscribe to our channel if you are yet to do so. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. We also encourage you to use the comment section to interact with us on areas where you are not cleared. Also, you can share the link with your friends so that they can also benefit from this class. Thank you and do have a nice day. See you in our next class.